So on the next slide, kiddos, you are going to be filling out some input-output tables. Sometimes, like this one, you will know all of the inputs, but you will not know the outputs, and you'll have to calculate those and fill out the outputs. Sometimes it'll be the opposite. Sometimes you'll be given an output, and you have to figure out what went into the function machine and came out as that output. Couple tiny details though that I do want to bring to your attention. Hopefully you've noticed in the Ed puzzle with the animation of the function machine, anytime that there was an equation on that function machine, it looked like this. The y is always on the left hand side of our equal sign. You'll notice that, and you'll be writing them this way when you, during our week this week, write equations to represent an input-output table. You always want to have your y on the left-hand side of the equal sign, and then the equal sign, and then you're always going to tell me what happens to the x. So whatever happens to the x, turns it into the y. So for instance, if I'm looking at this particular equation or rule for my input-output table, I see that two things are happening to x. The first thing is the x is being multiplied by 2, but then after that, there's one more thing that happens. Then we add 1. So x gets multiplied by 2, and then we add 1. So you'll notice sometimes an input-output table has one thing that happens to x. Sometimes there are two things that happens to x. So we just have to pay attention. We have to read the equation we're given to see what's going on with x, and then we know how to turn each of our inputs into our outputs. So let's do that. I'm going to go through my inputs, and I'm going to fill out the rest of my table. I see that my first input is 3. So I know that 3 is going to be multiplied by 2. So I'm going to show my work over here. If I replace the x from my equation, it's up here. I replace that x with each one of my inputs. So since our first input is 3, I wrote 2 times 3, and then I have to also remember to add my 1. 2 times 3 is 6, plus 1 turns into 7. So I know for the first one, the input of 3 gets me an output of 7. The second input is 4. So instead of 2 times 3 this time, it's going to be 2 times 4. Then we can add our 1. 2 times 4 is 8. And then when I add my 1, I end up with 9 as my output. When I use 5, I have 2 times 5 plus 1, which is 10 plus 1, which my output turns into 11. And then last but not least, my 6, 2 times 6 this time plus 1, which is 12 plus 1, which is 13. So if my x, my input, is 3, then my y, after I multiply it by 2 and add 1, turns into 7. If my input is 4, my x is 4, and I calculate times 2 plus 1, my y turns out to be 9. And that is how you fill out an input-output table. So you're going to give the ones on the next slide a try.